Hello everyone and welcome back to part 3 of Bomberman tutorial. So in the last video we went over how to create a player animation. We created our tile map and we discussed the little problem about snapping. When we are moving we probably will collide with some of the obstacles, so we want to fix that in this video and we'll add a walk animation to our player. Let's get started. First of all, you have noticed probably that I have placed the player in the top left corner. That's to make things easier, like that's the position we want the player to start in. You can change it to anything you want. And I have noticed that the player actually has an offset of 0.5 to be in an empty column. I don't like working with values like that, so I recommend also that you change this to a round number. This will be -11, and this will offset the whole map by 0.5, and like that we have the player set to a good position. Also, don't forget to fix that for the camera because we have set the minimum and maximum values. So let's change its position here. Also, the minimum position for X. And we will add 0.5 for the maximum X positions. This is the X column. Actually, I think I have placed these values wrong. This is 3 here. Well, let me check again what these values are, because in the last video I have probably placed them wrong. So -5.5 on X, and 3 is the maximum value for Y. Now for the bottom right corner, let's see what values are good. Let's try 13.5 here, which is good for X, and -6 here. Oh, actually I did not make it wrong, just the values happen to be the same for minimum X and Y. Okay, so let's get back to it. We put this to -5.5, and this will be 3 again. Now let's get to how to implement snapping for our player. So let's open the player script, and we will add a snap function. First of all, when do we want that snap to happen? We don't want it to happen while we are moving. We just want it to happen when we stop. So it will be called here. And here we will call our snap function. And now we're going to define it. So private void snap. And what we're going to do here, first of all, we're going to access the X and Y coordinates that we are currently having. We will do that multiple times, so in order to avoid the overhead of X in it, we'll just cache them here. So float X is rigid body dot position dot X, and same thing for Y. Now, when do we want that snapping to happen and to where? First of all, let's calculate the position that we want to snap to. So float, let's call it X snap to, and this will be equal to mathf dot round of X. But this might mess up calculations if we are working with negative numbers that are not round numbers. So in order to make everything simpler, let's just make this an absolute value. Then we will multiply everything by the original sign of X. Same thing for Y later. And that way we can work properly with it. So the conditions for us to snap to something are if the absolute value of X, sorry, I write it then explain what I'm writing here. So the absolute value of X is less than the value that we are going to snap to, plus a snap error that we are going to define. So let's actually define it now, so we get rid of that error. And we want it to be serialized because we're going to change this from the editor. So serialized field, and it's a float, private float, snap error. I found 0.5 to be a good value, and we will see what it does actually. So if the difference between X and the value that we are going to snap to, which is a round number, is plus or minus snap error. So if we exceed it by snap error, or we are under it by snap error. Let's duplicate this, change the signs here. So we are in the range of snap x minus or plus snap error. Also, we only want to snap if we stop moving in that direction. For example, if we are moving in the x-axis, we don't want to snap while we are still moving there. So if this is 0, also we want to add a flag that this is going to be round. So boolean, and this will be round x. Initialize that false. Same thing for y. We're going to do the same thing. And if these conditions are true, round x will be set to true. And we're going to do the same thing for y. So let's change these x's to y's. This will be y, and this will be, oh sorry, I messed up. This is going to be y, and this also will be round y. Now that we have determined the conditions for us to be snapping, we will actually change the values of our position depending on that. So how to do that is we want to do it within the rigid body. So rigid body.position equals new vector2, and if round x is true, so if we have to round, we will just round the values. So this is going to be mathf.round x, otherwise it's just going to be x. We won't change it. Same thing we're going to do for the y coordinate. So this is x, this is y, this is y, and this is y. Also, we want to change that when we are starting to move, not just when we are stopping. So this will be called also here. Now let's test our program. So let's go back to the editor. Zoom on the player to see how the collider is working. Let's hide the gizmo by clicking on this hand right here, and let's run it. So now you see that it's smoothed out and we are snapping, so we can't stop between squares. We are just snapping to the position in the middle of the column that we are into. And same thing for lines. Also, you notice that it is still smooth. We are not just hard setting it. You can play with the snap error here, but that will make you will give you the possibility to stop midways, like this. But it won't be a problem because we are fairly far from the center of the column, so the player can see that he's away from the collision safe area. I want to keep it 0.5 for now, and you might have noticed that if I'm walking to the left or to the right, the player is always facing right. So we want to fix that too. This is actually a pretty simple fix, and we're going to do it here when we have a new input. If moveDeer.x so is not 0 actually. What we're going to do is determine the way that we should be facing. So it's determined by the sign of the x coordinate, the x component of the move direction, and we're going to change the scale simply like this. So transform dot local scale equals new vector v transform dot local scale dot x multiplied by mathf dot sign move deer dot x, and for the rest of it to y and z we won't change anything. So this here will be y and this will be z. You notice also that we have a couple of warnings here about performance, so let's fix that. And this should be transform, actually not transform one. Well, we can just do it simply by caching the scale value. That would be better. So vector 3 scale equals transform dot local scale, and simply we are just going to do this here, here, and here. Let's go back and test the game. Oh, nothing is wrong here. Let's check the code if we did something wrong. So, oh, this should be local scale, no, not local position. This should fix it. Let's test it again. You see that we can actually it's not working properly. So what we did here wrong was, let's go back here. We're reading the scale value. We're multiplying it by the sign of our input. And the problem actually is here because suppose the scale is actually negative, so we are facing left and we will be facing left again. We press left again, so -1 by -1 will be +1. This actually should be an absolute value, so mathf.abs of the x component of our scale. This now should fix it. I don't want to edit out moments like this of typing something wrong or not paying attention to something, because they are pretty useful for people to learn how to detect problems and how to debug. So now it's working properly. Let's go on to the next step, where we're going to add animations to our player. Let's stop this, and we're going to navigate to our folder.